Hi, I'm Christoph Brown. I'm a junior here at North Carolina State University. I study electrical engineering and computer engineering. Today, I'm going to show you a brief lecture on the different types of touchscreens as well as how a few of them work. So let's get started. How do touchscreens operate? Believe it or not, touchscreens operate very similarly to a basic circuit in which you have a power source, or in this case, the internals of the system connected to a circuit component. However, for touchscreens, the circuit component is actually a point of contact on the screen. So we look over here on the left side, we have a voltage source, or the internals of our device, connected to a bunch of opens. When a touchscreen is not being touched, these remain as opens. Depending on the type of touchscreen you are using, once a point of contact is made on a touchscreen, these opens will then close, thus completing a circuit, and then our devices will register our point of contact on the screen. There are two primary types of touchscreens used today. That is a resistive touchscreen as well as a capacitive touchscreen. In a resistive touchscreen, there are two main layers. This includes the conductive layer as well as the resistive layer. The conductive layer in this case serves as our open circuit. These two layers are separated by tiny dots called spacers. The resistive layer literally resists our touch on the screen. So what happens is once a point of contact is made on a resistive touchscreen, the resistive layer will then flex, allowing it to make contact with the conductive layer. Once a point of contact has been made with the conductive layer, the circuit is then completed, allowing our device to register where a point of contact has been made. For capacitive touchscreens, there are three layers: an indium tin oxide layer, a glass substrate, as well as a conductive layer. These types of touchscreens do not flex like a resistive touchscreen. So what happens instead is that there is a constant electric field on the interior of our device. A point of contact is then made with our finger or a conducting stylus, and once this happens, a potential drop occurs between the screens, allowing our device to register where the point of contact has been made in this case. There are several advantages and disadvantages to either a resistive touchscreen or a capacitive touchscreen. With a capacitive touchscreen, you can make multiple points of contact. However, you must be using bare skin or conducting stylus, and you cannot use a capacitive touchscreen when wearing gloves, for example. The older resistive touchscreen tend to be more durable, and while they're not made of glass, they're less prone to shattering. However, frequently, these types of screens will reflect ambient light and cause a glare that is unfavorable to most users. So, how does this relate back to electromagnetics? Recall that a dielectric is a material in which there is no free charge whatsoever. Our glass substrate in the capacitive touchscreen serves this exact purpose. Charge cannot naturally dissipate through glass. However, due to a glass substrate, when using a touchscreen, due to the electric permittivity, charge can transmit through it once contact is made with our conductive skin. This is, as a matter of fact, the reason why you cannot use capacitive touchscreens while wearing gloves, as the insulation is far too great. So why are touchscreens so important? Can you recall the last time you went 24 hours without using a touchscreen of some sort? You probably can't. They exist already in our smartphones, computers, and tablets, and are slowly being integrated into our cars, refrigerators, and wearable technology. A number of innovations have also been made over recent years, such as Apple with their 3D Touch or Samsung with their Edge screens. That all being said, I hope you learned something new. Thank you very much for joining me, and have a wonderful day.